Question 2. Show that cosine is an even function but sine is an odd function. Okay, so let's try to understand both sine and cosine functions here, right? So let's do cosine function first. So it is cos, let's say cos theta is a cosine function. So let's sketch it. So even is symmetric about y-axis. That is even function, right? If you sketch a cosine function, normally we do like this. Do you understand? Like this we do. But it is a periodic wave, right? And it extends both sides. Do you see that? It extends both sides. And that is how it is. As you can see, it is symmetric about the y-axis, correct? If you take any point here, it is kind of a mirror image. If you keep a mirror on y-axis, so this is your theta axis, and that is y equals to cos of theta, right? So therefore, we see that cosine is a symmetric function. And symmetric really mean is that cos of minus theta is actually equals to cos of theta, right? So that is the way to see it. Even using cast rule, we can prove it. How? Let's write down the cast rule, which is C-A-S-T. Where is cos positive? All are positive here and cos is positive here, right? So if you have an angle alpha here, correct, it will give you a positive value. But if I have minus alpha, that will also be positive for cos. Do you see? So for both alpha or minus alpha, we get same value. Or for cos theta or minus theta, we get the same value. Since cos is adjacent over radius. Adjacent here, x is positive. Do you see? It's positive axis. So both are positive. And so we can use x and y points. So this point is x and y for us. And that point will be x and minus y for us. Do you get it? So from these points, what is cos of theta? So we can write here cos theta is actually equals to x over r, right? What is cos of minus theta? Is also equals to x over r. So this is the way we can show it using our coordinate points. So both ways is good enough. Now let's look into the sine function. And I think you can do it now taking help from here. So let's consider sine theta, right? So let me draw this time this diagram here for sine. Okay, so sine function when we draw like this. Correct? It is periodic, it extends. Do you see that? It extends like that. Now it is symmetric about origin. Do you see the symmetry here? It is symmetric about origin. If I draw a line here, we will have same reflected points. Any point, there is an image here, right? So symmetric about origin, right? And therefore it is odd symmetry. And this is symmetric about y-axis. Let me write down. And that is even symmetry, right? Now that is from the graph, correct? And that really means is sine of minus theta is equals to minus sine theta. Correct? Sine of minus theta is minus sine theta. And now let's look into a coordinate plane, right? So we'll draw the same thing here, slightly bigger this time. So let me take a point xy here. So its mirror image will be here reflected. Okay. So this point, let us say this point is xy. So when you reflect it on for minus, let's say this angle is theta, and this angle will be minus theta. And this point will therefore be x is positive. Do you see that? Let's say radius is r for us. So this point will be x and minus y. Minus y. Do you see it's going down? Now what is sine of theta? So sine of theta is equals to y over r. What is sine of minus theta? Minus y over r. Do you see that? Minus y over r. And therefore, Sine of minus theta is minus of sine theta. Do you see? So minus y over r. That means minus of sine theta. And that means it is even symmetry. Do you understand? So that is how we do it. And for you try to figure out how about tan theta. Is it even or odd? So you can also use a relation tan theta is sine theta over cos theta, and have a third method of proving that tan theta has odd symmetry, right? So try to prove tan theta as odd symmetry using graph, using x and y coordinates, right? So tan of minus theta, same x and y coordinates, and also using sine and cosine ratio. So 3 ways to prove that tan theta has odd symmetry. Okay, thank you.